Hi everyone, so today's class we're going to go on to chapter 22, families of organic compounds, and we're going to be looking at chloroalkanes today. So they're another example of tetrahedral compounds. So we've already looked at alkanes, so we've ticked that one off. Remember, a tetrahedral carbon is one that has 4 single bonds coming from it. So chloroalkanes are alkanes where one or more of the hydrogen atoms has been replaced by a chlorine atom. So this is a regular alkane, but one or more of the hydrogen atoms in the alkyl chain, in the alkane chain, is going to have been replaced with a chlorine atom. We'll see these pop up again later on, but they're synthesized in the lab, so we make them in the lab. They're used as solvents. They're not soluble in water, and they dissolve in non-polar solvents like cyclohexane. So just having a look at them here, chloromethane is methane where one of the hydrogen atoms has been replaced with a chlorine atom. CH4 becomes CH3Cl. Dichloromethane, that as the name might suggest, di meaning two, chloro meaning chlorines. So we've got methane where two of the hydrogen atoms have been replaced with chlorine atoms. Trichloro, three of the hydrogen atoms have been replaced, and tetrachloro, four of the hydrogens in methane have been replaced with chlorine atoms. Just showing you the structure of those there. Usually if we were in class I would be getting you to build these with the Molly-Mod kits that we used before. So I've just put in the image there to show you what they would look like. We've got chloromethane, so we build methane and then we replace one of the hydrogens with a chlorine atom. Dichloromethane, two chlorine atoms there. Chloroethane then would be ethane, two carbons, with one hydrogen replaced with a chlorine molecule. 1,1-dichloroethane, so we've got two, so dichloro meaning two chlorines. Where are they on the ethane chain? They're both on carbon number 1. So 1,1-dichloroethane. And then 1,2-dichloroethane, so this is a structural isomer. These two are structural isomers of each other. We'll see more of those in a second. So all the difference here, we've got our ethane chain, we've got dichloro, so there should be two chlorines on it. Where should they be? One on carbon 1, one on carbon 2. Naming the chloroalkanes, we've basically done that just there, but just to give you the outline that we have here. So the last part of the name comes from the base alkane. So you'll have ethane, methane, propane, butane, pentane at the end of it, with the chloro in front. The number of chlorine atoms is indicated by mono, di, tri, tetra. You won't go past tetra. So the number of chlorines is put in front of that. So all one word, trichloromethane. And the position of the chlorine atom or atoms is given by a number before the name. So these three numbers here tell me where my trichloro, I've got 3 chlorines on the propane molecule, and these numbers tell me where they go. Just showing you that here. We've got propane, so I've got a 3 length carbon chain. Trichloro, meaning in there I should have 3 chlorines. Where am I putting them? 1 on carbon 1 and 2 on carbon 2. And that's the structure made up for you there as well. Structural isomerism in chloroalkanes. So again, in regular alkanes, we looked at isomers of butane and butane and pentane. And you need to know those for alkanes, and you also need to be aware of them for chloroalkanes. So here, if we just look at these molecules, you can see they all have 4 carbons. They all have 9 hydrogens and they all have 1 chlorine. So that makes them all isomers of each other. They all have the formula C4H9Cl. So an isomer, just to remind you, is a structural isomer is molecules that have the same molecular formula but different structural formula. So they've got the same molecular formula but different structural formulas. So all of these here are just the 4 isomers of butane, but we've got 1 chlorine in each of them there. So you just need to be aware of that as well. Nothing different to what you've seen before. Hopefully you'll be able to name these as well. I'll give you some questions in a second. Just some properties that you need to know. Physical state, they are all liquids except for the first two, except for chloromethane and chloroethane. These are gases at room temperature. Boiling points are higher than the corresponding alkane due to the polar carbon to chlorine bond. So if we just look here, our boiling points are due to the fact, so I'm going to look at 1-chlorobutane here. So if we look at this, if we look at this part of the molecule just here, you'll notice we've got a carbon and a chlorine. Now, if you look at their electronegativities, they're going to give you a polar bond. So we do have 1 polar bond in the molecule. And our boiling points occur by trying to separate 1 molecule from another. So if we had a mixture of the 2 of these isomers here, we would have a polar bond between carbon and chlorine, a polar bond over here between carbon and chlorine. And what would happen when they're mixed together, when they come close to each other, they're going to form intermolecular bonds, stronger intermolecular bonds than if the chlorines weren't there, if we just had a completely non-polar molecule. And so it would be harder to separate the molecules. That's why on the next side the boiling points are higher. It's harder to separate them due to the polarity of the bond. It's going to cause or create stronger bonds between the molecules. As we said in the beginning, they're not soluble in water. They only have a very tiny portion of polarity in them. So they are instead soluble in non-polar solvents, for example, cyclohexane. Because of their lack of polarity, they themselves are very useful solvents. So we'll often see chloroalkanes being used as solvents when you're trying to remove something like grease or oil from machinery, or if you take your clothes to the dry cleaners to get out stains like oil and grease as well, they will use a chloroalkane solvent to remove them. So if you could pause here and answer these questions. I will be waiting over on Microsoft Teams for you to submit your answers to these, hopefully within the next 10 minutes, let's say. I was going to say 5, but I'll give you 10 minutes to get this done, and I'll be waiting over there to have you submit them.